Okay, picture this. It's Black Friday. Your app goes from 10,000 users to 1 million, just like that. You're facing an absolute tidal wave of traffic. So what happens next? Does it just crash and burn, taking all your revenue and your company's reputation right down with it? Or does it just scale seamlessly, going from 10 to 1,000 pods in minutes, all while your engineers are just chilling, not even breaking a sweat? Well, the difference between those two scenarios is Kubernetes Autoscaling. This is the secret sauce, you know? It's how giants like Netflix and Spotify handle hundreds of millions of users without even blinking. So, you want to know how they do it? Let's break down their playbook. To get this, you really only need to understand three core ideas. First, you've got the horizontal Pod Autoscaler, or HPA. It just adds more pods. Easy. Second, the vertical Pod Autoscaler, or VPA. This one makes your existing pods bigger. And third, the Cluster Autoscaler, or CA, which adds more machines when you're all out of room. You master these three, and you're golden. All right, let's start with the big one, the one you're going to use like 90% of the time, the horizontal Pod Autoscaler. Think of this as your frontline defense against those sudden traffic spikes. So, how does this thing actually work? Well, it's a really simple and kind of elegant control loop. First up, the Kubernetes metrics server is constantly collecting data. CPU, memory usage, that sort of thing. Then, every 15 seconds, the HPA controller checks those metrics. It then does a quick calculation to see if you need more pods or maybe fewer. And finally, it just tells your deployment, hey, scale up, or hey, scale down. That's it. The real magic, though, is in that calculation. The HPA's entire job is to figure out just one number. What is the desired number of replicas? And believe it or not, the formula is surprisingly simple. It all starts with the number of pods you're running right now, and then it multiplies that by a special ratio. And that ceil function you see, that just means it always rounds up to the next whole number. Because, you can't have half a pod running. And boom, here's the whole thing. That ratio is just your current metric value divided by the metric value you're aiming for. So think about it. If your pods are running way hotter than your target, that ratio is going to be bigger than 1 and you'll scale up. If they're running cool, the ratio is less than 1 and you scale down. Simple as that. Let's make this real. Imagine you have 2 replicas, but man, they are struggling at 80% CPU. Your target, your happy place, is 50%. So the HPA just plugs in the numbers. 2 times 80 divided by 50. That gives you 3.2. It rounds up, and bam, it instantly scales your app to 4 replicas. Load handled. And you're not just stuck with CPU. HPA is super flexible. It can scale on standard stuff like memory, or you can use custom metrics from inside your cluster, like requests per second. You can even use external metrics from your cloud provider, like say how many messages are piling up in an AWS SQS queue. So the main thing to remember with HPA is this. It adds more identical copies of your pod to handle more load. That's horizontal scaling. If that makes total sense, do me a favor and comment HPA Master down below. But hey, what if just adding more pods isn't the right answer? What if you don't need more pods, but you need stronger pods? Well, that's exactly where the vertical Pod Autoscaler comes into play. This really nails the core difference, right? HPA scales out horizontally, like adding more lanes to a highway. VPA scales up vertically. It's like turning your car into a monster truck by jamming more CPU and memory into it. This is absolutely perfect for things like databases or other stateful apps that you can't just easily copy. Now, VPA has a few different modes you can run it in. Off mode is cool. It just gives you recommendations without actually doing anything. Initial mode applies the right size when a pod first gets created. And then there's auto mode, which will actually evict your pods and recreate them with new optimized resources. But, and this is key, that does mean your pod has to restart. Gotta remember that. And here is a super critical tip, especially if you're studying for any kind of cert exam. You absolutely cannot have VPA and HPA trying to control the same metric, like CPU. Think about it. They'd be constantly fighting each other, creating this scaling loop nightmare. You have to pick one or the other for each metric. Okay, so your HPA is doing its job, scaling up pods like crazy. But what happens when you just run out of space? You've filled up all your machines. Well, that's when you call for reinforcements with the Cluster Autoscaler. Let's walk through the whole story here. A massive load hits your app.
HPA springs into action and tries to create a bunch of new pods. But the Kubernetes scheduler looks around and says, uh-oh, there's no room. So it puts the pods in this pending state. The Cluster Autoscaler sees these poor pending pods, realizes the cluster is full, and boom, automatically calls out to your cloud provider for a brand new node. Problem solved.
And this isn't some kind of black magic. The Cluster Autoscaler is smart. It works by talking directly to your cloud provider's infrastructure. We're talking AWS autoscaling groups, Google's managed instance groups, or Azure's virtual machine scale sets. It just asks for more machines when you need them and gets rid of them when you don't.
Okay, now for the pro move. We've talked all about scaling up, but what about scaling down? I mean, true efficiency is when you have zero traffic, you have zero pods, and you pay zero cost. That is the incredible promise of serverless on Kubernetes.
And honestly, this is a total game changer. Just imagine your dev environments or other non-critical services just automatically spinning all the way down to nothing when they're not being used. And then, the second a request comes in, they pop back to life in seconds. The cost savings there are just massive. To pull this off, we need a smarter trigger. See, HPA is resource-based. It's reactive. It waits for CPU or memory pressure to build up. But tools like KDA are event-based. They're proactive. They don't wait for your pods to get overwhelmed. They scale based on the number of events sitting in a queue, waiting to be processed. The two titans in this space are Knative and KDA. Knative is a whole platform that gives you that scale to zero magic, plus really sophisticated traffic splitting. And it's actually what powers Google Cloud Run. Then there's KDA, a CNCF graduated project that is laser-focused on event-driven autoscaling. It has over 70 built-in scalers for things like Kafka, RabbitMQ, and Prometheus. It's awesome. So let's put all the pieces together. Let's build your complete master plan for scaling any application on Kubernetes. Here it is. This is your complete toolkit. You use HPA to add more pods for your stateless stuff. You use VPA to right-size your pods, making them bigger for your stateful apps. You use the Cluster Autoscaler to add more nodes when you run out of physical space. And you use Knative or KDA to get that advanced event-driven scaling that takes you all the way down to zero. So let me ask you, are you ready to handle 1 million users? With this toolkit, the answer is a definitive yes. You now have the fundamental patterns used by the biggest tech companies on the planet. If you are ready to build massively scalable systems, comment "scale to millions" below. And please, make sure you subscribe, because next time we're diving into the entire CNCF ecosystem that makes all of this possible. You don't want to miss it.